Hey everyone, welcome. We're doing a deep dive today all about Java and software testing. Making sure those apps and systems we use every day actually work. Whether you're getting ready for a big meeting, just want to stay up to date with what's happening, or are just curious, we've got you covered. We've got some great online articles for this deep dive. So get ready to find out why Java is so important in software testing, what tools and skills you need, and how it all connects to making software that's reliable and high quality.
It really is fascinating. I mean, we use software all the time, right? But most people don't think about all the work that goes on behind the scenes to make sure it's reliable and does what it's supposed to.
Yeah, it's true. So let's get into it. One thing I've read is that Java is really popular, especially for these big, complicated applications. Is that why it's so important when it comes to testing?
It's a big reason, yeah. Think of it this way. If you're building a skyscraper, you need everyone on the construction crew to understand each other, right?
Hmm.
To speak the same language. Java is kind of like that shared language for software developers, especially when you're talking about those huge enterprise-level applications. And when you have so many developers using Java, it makes sense that it becomes a key language for testers too.
Okay, that makes sense. So does that mean there are lots of testing tools that are made specifically for Java?
Absolutely. It's
Yeah.
like you walk into a really well-stocked workshop and you've got the right tool for any job you can think of.
Like what? Can you give us an example?
Sure. For unit testing,
Hmm.
where you're checking the individual pieces of code, the go-to is JUnit. It's kind of the workhorse of Java testing. It makes sure each piece of code is doing exactly what it should.
I see. But then how do you test how all those pieces work together? Is there a tool for that too?
You bet. When you want to look at the bigger picture, see how all the different parts of your application interact, that's where TestNG comes in. It's kind of like a JUnit's more powerful cousin. It can handle more complex scenarios and figure out what happens when those different pieces of code depend on each other.
Wow, it sounds like Java testing is really thorough. But what about web applications? Those seem totally different.
Right? And that's why we have Selenium. It's like having a robot user that can interact with your web application,
Yeah.
clicking buttons, filling out forms, going from page to page, all while checking if everything is working the way it's supposed to.
So Selenium helps make sure the website is actually usable from a user's perspective. What about mobile apps? Everyone's using those these days.
And of course, Java has a tool for that. Appium is what you use for testing mobile apps, no matter if they're on Android or iOS.
That reminds me of something I read about Java being write once, run anywhere. Does that apply to testing too?
It's super important. Imagine you're testing a mobile app that needs to run perfectly on all these different devices and operating systems. It could be a nightmare. But because Java is platform independent, you write your test code once, and you can run it on all sorts of platforms without changing a thing.
So it's like having a universal adapter for your testing code that must save so much time.
Exactly. It makes testing so much faster and makes sure things are consistent no matter what environment you're in.
That makes a lot of sense. Speaking of making things faster, developers are always updating and releasing new versions of their software. How does Java testing keep up with all that?
Well, that's where integration comes in. Java is really good at working with other development tools and systems, especially the ones used for continuous integration and continuous deployment, CI/CD. It's kind of like an automated pipeline where code is always being built, tested, and released.
So Java testing is built right into that process.
Absolutely. It makes sure that every time the code is changed, it gets thoroughly tested before it goes live. That way, you can prevent those bugs from sneaking into the final product.
This all makes me wonder about what it takes to be a good software tester in the Java world. Where would you even begin?
Well, just like with anything you want to get good at, it starts with the basics. You need to understand the core concepts of Java. Things like variables, data types, how to control the flow of your code, how to define and use methods, and the ideas behind object-oriented programming.
So it's kind of like building a house. You have to understand the materials and how they go together before you can actually start building.
That's a great way to put it. And once you have those basics down, you can move on to mastering the testing frameworks themselves, like JUnit and TestNG, which we talked about earlier.
Right, those frameworks. What specifically would someone need to learn about those?
Well, you'd need to know how to structure your tests, how to write those assertions to make sure your code is behaving correctly, and how to organize your tests to make them easy to work with.
It's like learning the language of software testing.
You got it.
Yeah.
It's about learning how to communicate your testing goals clearly and effectively within that Java ecosystem. And there's another tool that's super helpful here, Mockito.
Mockito. I haven't heard of that one.
So let's say you're testing a part of your code that depends on other parts that aren't ready yet, or maybe they're just really complicated to set up for testing. Mockito lets you create these mock versions of those parts. So you can isolate the specific code you're testing and make sure it works without worrying about all the other stuff.
So it's like using a stunt double for a dangerous scene in a movie. You can test the risky part without putting the whole production in danger.
Exactly. It gives you a lot more control and flexibility when you're testing.
We've covered a lot of ground already. We talked about why Java is so important for testing, looked at some of the key tools, and even talked about some of the skills you need. But it feels like we're just getting started. What else is there?
There's so much more to discover. We haven't even touched on all the advanced techniques and specialized areas within Java testing. Things like test automation, where you can write scripts to test your software automatically, database testing to make sure your app is handling data correctly, performance testing to see how your software performs under pressure, and version control to manage all those changes to your code over time.
Wow, there's a lot to unpack there. I'm definitely interested to learn more.
Well, we're going to dive into all of that after a quick break. Stay tuned.
We're back and ready to jump into those advanced Java testing techniques you mentioned. Where should we start?
Let's talk about test automation. It's basically like having a bunch of robot testers who never get tired and work 24/7. Selenium WebDriver, remember that one? It's great for web application testing. You can write scripts that automatically do all sorts of things with your web app, clicking buttons, filling out forms, navigating pages, and checking that the results are what you expect.
So instead of manually checking every single little change you make, you can set up these tests to run all on their own.
Yeah, exactly. And that's so important when you're working in a fast-paced environment where you're constantly updating your code. It frees up the human testers so they can focus on the more complicated stuff.
Makes sense. But wouldn't it be hard to keep track of all those automated tests? Especially if you're working on a really big project?
That's where version control systems come in, like Git. Imagine you're on a team and everyone's making changes to the code and the tests. Git helps you manage all of that. It keeps track of who did what and prevents conflicts from happening.
So it's kind of like a time machine for your code. If something goes wrong, you can go back to a previous version.
Exactly. It keeps your project organized, and it's really important for collaboration.
Okay, version control. Got it. What else is there?
Well, sometimes you need to test just one piece of your code in isolation, without all the other parts and the complexity of a real system. That's where mocking and stubbing come in handy. So let's say you're testing a part of the code that relies on a database, but setting up a real database just for testing, it'd be really time-consuming and messy. Mocking lets you make a fake version of the database that acts just like the real one, but only for testing purposes.
So it's like you're building a little miniature version of the real system just for testing.
You got it. That way you can make sure that one part of your code is working without having to worry about everything else.
This all sounds so organized, so efficient. But what about when you do get those bugs? How do you find them and fix them?
Well, that's when good logging and debugging skills become really important. Java has these great libraries like Log4j and SLF4j. They let you record what's happening in your code while it's running. It's like having a black box recorder for your software.
So if something goes wrong, you can go back and see exactly what happened.
Exactly. And on top of that, the modern Java IDEs, like IntelliJ IDEA or Eclipse, have really amazing debugging tools. They let you go through your code line by line, look at variables, and really understand how your code is behaving.
So it's like a combination of leaving a trail of breadcrumbs in the form of logs, and then having the tools to follow those breadcrumbs to the problem.
Right. And sometimes those bugs have to do with how your Java code interacts with a database. To test that, you can use in-memory databases, things like H2 or Derby.
In-memory databases, what are those?
Think of them like temporary databases that only exist in the computer's memory while you're running your tests. It's a super fast and convenient way to test how your code interacts with the database without setting up a whole database server.
So it's kind of like a sandbox for your database testing. You can experiment without messing with the real data.
Exactly. Keeps your tests nice and isolated.
Okay. We've talked about web apps and mobile apps, but a lot of software these days relies on APIs, those connections that allow different apps to talk to each other. How do you test those with Java?
API testing is really important. You've got to make sure that the different parts of your system, or even completely different systems, can communicate without any problems. Tools like Rest Assured make it really easy to write tests in Java that send requests to your APIs and check the responses.
So it's like making sure everyone is speaking the same language and the information is being exchanged correctly.
Exactly. And that brings us to the end of our look at some of those advanced Java testing techniques. I hope this gives you an idea of how powerful and versatile Java is when it comes to software quality.
Definitely. We've covered so much, from automating tests and managing changes to debugging errors and testing APIs. Java really does offer a complete toolkit for all the challenges of software testing.
It does. And as we move into the final part of our deep dive, I think it's important to step back for a minute and think about what we've learned and why it matters.
Wow, we've covered a lot of ground in this deep dive, from the basics of Java all the way to those advanced testing techniques. It's really clear to me now why Java is so important in making sure software works well.
Yeah, and it's not just about the tools, you know? Even though they are pretty impressive, it's more about the whole philosophy behind Java. It was designed from the start to be reliable and portable. That whole write once, run anywhere idea we talked about, that's crucial for creating software that's really solid and trustworthy.
So it's like Java has this built-in quality control right from the beginning.
Exactly. And that extends to the whole testing ecosystem. The fact that there are so many different tools for Java testing means you have what you need to test your software really, really thoroughly.
Thinking back on everything we've talked about, what are some of the key takeaways you hope people listening are taking away from this deep dive?
I hope they realize that testing isn't just something you do at the end. It's a key part of the whole software development process. And Java gives you the tools and the language to make testing efficient, effective, and even, dare I say, a little bit exciting.
Yeah, I think that's a great point. What advice would you give to someone who's just starting out with Java testing?
Don't be afraid to jump in and try things. There's so much out there. Online tutorials, open source projects, tons of resources. Get your hands dirty, experiment, and don't worry about making mistakes. That's how you learn it.
You know, it's amazing to think about all these awesome tools and techniques, but software is always changing. What do you think the future holds for Java and software testing?
That's a great question. The world of software never stands still. One area I'm really excited about is how AI and machine learning are going to impact testing.
Oh, interesting. So are we going to see AI-powered testing tools that can find bugs before they even happen?
It's definitely a possibility.
Yeah.
AI could analyze huge amounts of code and data to find patterns and potential problems that human testers might not catch.
It's like having a super smart testing assistant. But even with all these advances, it seems like human testers will still be really important.
Oh, absolutely. AI can help us a lot, but it can't replace human creativity, critical thinking, or our problem-solving skills. It's about finding the right balance, using technology to make testing more efficient and powerful, but still recognizing how valuable human expertise is.
That's a great point to end on. As we wrap up this deep dive, is there any last thought you'd like to leave our listeners with?
How about this? The world of software testing is always changing. There are always new tools, new techniques, and new challenges popping up. The important thing is to stay curious, be ready to adapt, and never stop learning. If you do that, you'll be ready for anything the future of software testing throws at you.
And with that message of continuous learning, we're going to wrap up this deep dive into the world of Java and software testing. We hope you enjoyed it and that you feel inspired to keep exploring this fascinating field.